So my second and last story is has to do with, and this is something that you might have heard about in the news, the idea that we've discovered a planet and we've found water vapor in its atmosphere. And this is another planet that was discovered by Kepler, K2-18b. And K2 refers to a second phase in the Kepler mission. But basically, what astronomers have found is that around this very reddish, low luminosity star. So this is a star that's lower mass than our sun. It's what we call a red dwarf. I think it's about 40% or 60% the size of the mass of our sun. So it's putting out less energy for the most part. And it's located just over 100 light years away. And the planet is orbiting about 0.14 astronomical units, so about 14% the distance between the Earth and the sun. And to give you an idea of what that means, Mercury is orbiting about 0.4 astronomical units. So it's orbiting much closer than Mercury does in our solar system. But because the star is less massive than the sun, it's putting out less light and less heat. And that means the habitable zone, the orbital distance in which liquid water can exist on the surfaces of rocky planets like the Earth, that zone is actually closer in. And so it turns out that this planet lies in the habitable zone of this star. So the habitable zone is between 0.12 and 0.25 astronomical units. And so this is really exciting. And what's also interesting is that this world is not quite Earth size. It's actually about 2 times the diameter of the Earth, and it's about 8 times the mass of the Earth. And so compared to, it belongs to a category of objects that we call super Earths, meaning it's between the Earth in size, and the next largest planets in our solar system are Uranus and Neptune, which are about 4 times the diameter of the Earth. So twice is somewhere in the middle between 1 and 4 times. And so this is a very unique category of planets, and there are actually lots of super Earths out there. It just so happens that our solar system doesn't contain a super Earth. And it also turns out that as we're looking at more and more and discovering more and more planets in habitable zones, more and more of them are being discovered not around solar, clicked on the wrong button, not around solar type stars, which are the G stars. So we've only found 1 or 2 planets around G-type stars, but when we go looking at redder stars and redder star still, that's where we're finding more Earth-sized or roughly Earth-sized planets that are in orbit around the habitable zones of those stars. So basically, K2-18b falls into this that bottom row of planets. And this plot is a few years old, so from 2017, but it shows you along the bottom the orbital period of the planet, and then along the side, the size of the planet. And so what this means is that the further out you are, the more distant the planet is orbiting, and the higher up you are, the larger the planet is. And so our Earth is orbiting around the sun 365 days a year, so it's somewhere around here, and here an Earth-sized planet would be right about there. And so we haven't found any direct analogs to our solar system, meaning an Earth-sized planet around orbiting at roughly the same distance as the Earth orbits the sun. But what we found are planets that orbit closer and planets that orbit that are much bigger. And that's just because those are all objects that are easier to find. And here is another plot, also a couple years old, but they show the couple dozen planets that have been found, or that have been confirmed or found, or that are candidates that are in orbit around the habitable zones of their stars. And so the G-type stars are up here, and when we get to redder and redder M dwarfs down here, so there are definitely more M dwarf stars with planets in or close to their habitable zones, but we're starting to find more of them. So the yellow dots are the candidates, and dark yellow dots are the latest candidates that have to be confirmed. And so the paper that was part of the big press release just a couple of weeks ago came from Angelos Siaras and his team, which are based in London, and they published the paper in Nature Astronomy about water vapor in the atmosphere of this 8 Earth mass planet. And what they did was to use the Hubble Space Telescope and to look at the light coming from the planet very carefully through different wavelengths. And so on the left, you see those light curves that we saw earlier before. But what they did was to observe the light at multiple infrared wavelengths. And so that's what these numbers represent. These are the wavelengths in microns. And the idea is that when you're observing the light from the star, remember these stars are so distant that you can't, that you're only seeing a pinpoint of light. And so you can't see the disk of the star, you can't make out the planet itself, you're only seeing a pinpoint of light from the star. But when the planet is passing in front of the star, some of that light will travel through the atmosphere of the planet. And if there are gases in that atmosphere that block certain wavelengths of the light because of the distinct composition of that atmosphere, then you should be able to detect it. And so that's what they did, where they took the Hubble observations, and these are now broken out in wavelength in the infrared. And so these are those data points, and you can see that the data points aren't in a line, but they're dips and peaks, and they ran computer models to basically model the atmosphere. And so these atmospheres all contain substantial amounts of hydrogen, but some of them have water plus clouds, some of them have water plus substantial amounts of nitrogen, and some of them have water only with no clouds. And they show that their models more or less roughly agree with the data points that they observed. And of course, the data points have very big error bars. That's what those dark vertical lines are. But it seems that at least from these observations, they have confirmed the existence of water vapor in the atmosphere of K2-18b. Now, that's not quite the end of the story, although it is kind of the final conclusion of this paper, because I was reading the paper and then I noticed this one really interesting comment in the back. It says, these observations were observed as part of the Hubble Space Telescope proposals 13665 and 14682 by the principal investigator or the principal scientist, Bjorn Benecke. Now, what's really interesting about this is that Bjorn Benecke does not show up in the author list. Okay, and so the way that Hubble Space Telescope observations work is that you as an astronomer will propose to the Hubble Space Telescope office to say that you want to make these observations, and then your proposal is actually peer reviewed, meaning it's judged against all the many hundreds, if not thousands, of other proposals that come in. And so the Hubble but I think the oversubscription rate, meaning the number of proposals versus the ones that get accepted, is on the order of about 20 to 1. So it's actually a very competitive program. And so when you get Hubble time, it's actually, it shows that you've done your homework and have proposed scientific research that other astronomers think to be really worthy. So it's a big deal when you get Hubble time. But what happens is that when you get that Hubble time, your data stays proprietary for 1 year. And so you basically get 1 year to work on it. And after that 1 year, it gets put into an archive that's then open to the public, meaning any astronomer who knows how to go out and get that data can now analyze it. And so what happened was that this data, and it was actually multiple years worth of data, was held. And you can see that the data was taken from 2015 to 2018. Series 2018, and then after that proprietary period, the data was released sometime this year, and these authors from London sprung upon that, and they scooped the original astronomers who proposed to make these observations. And what's really funny, well, maybe not so funny if you're these astronomers, I went and looked online. There's an online archive of papers that may not have been accepted by a journal because they haven't been peer reviewed, but astronomers can still post them. And so on basically the same date that the press release came out, Bjorn Benecke and his team posted this paper, and this paper hadn't been accepted by a journal yet, but obviously they had heard that the other paper was coming out and was accepted, and so they spent some all-nighters to put this paper online, and if you go and look at their paper, they get very similar results, but it's again, maybe not so funny to the astronomers who had the setback, but it shows that you can't sit on your data. You really have to work on it and put it out.